Hello, mathematicians. This is Mrs. Post here, and this is your Algebra 2 lesson for April 15th. We are going to work with radicals some more. Today we're going to add and subtract them. So we're going to talk about like terms and like radicals in just a few minutes. But the first thing I want to do is go back to your classwork, go back to your assignment from the 14th and kind of go over the solutions. You're welcome to pause the video and take a look at your work and then check it and see if you got the same solutions as I did. The solutions are written in the text, the typed font, and I just went ahead and showed my work out next to it. So 1, 2, and 3 I'm not going to go over because we've been working on simplifying them for like a few weeks since even before the maze. So that's been like 3 weeks now. So, but the division is the new part, and that's the part I want to go over. So I just want to remind you that probably for most of you, the trickiest part was the rationalizing the denominator, and that's the part that's new, and that's okay. But that's the part that you guys have to work on, and you have to understand what that means. You're welcome to Google it. I taught it yesterday, and you're welcome to listen now and try to see if it makes a little bit more sense. So I'm just going to briefly go over number 4. When you simplify the square root of 36, you guys should get 6. When you simplify the square root of 125, hopefully you guys will see that there actually are 3 5s. So that is 5 times 25. And so when you simplify that, you get 5 times the square root of 5. So remember, you cannot have a radical on the denominator. You can't do it. You are not allowed. So because of that, you have to rationalize the denominator, which just means multiply the top and the bottom times whatever you need to get rid of that radical. All right, so we know that if you multiply the square root of 5 times the square root of 5, that's going to give you the square root of 25. And 5 times the square root of 25 is 5 times 5. And when you get that, that's how you get the 25. So that's how you get that final solution right there with the denominator of 25, and the numerator is just 6 times the square root of 5. The numerator doesn't really do much. You just kind of get that radical kind of tacked on to it, but that's where the bottom will definitely make sure you know you're done when you follow the rules and you don't have a radical on the denominator anymore. With number 5, you'll see some of the solutions have absolute value bars. I'm not going over those with you, so you can just kind of disregard them for now. But hopefully you guys were able to get as far as a to the power of 3b times the square root of b, and your denominator was 7 times the square root of 2. You cannot have a radical on the denominator, so the best way to get rid of it is to multiply it by another radical. So hopefully you guys were able to see that, okay, well, what if I have 7 times the square root of 2 times another square root of 2, that's going to give me 7 times the square root of 4. And I know the square root of 4 is 2. So 7 times 2 is 14, and that's why your denominator is 14. Okay, so be really, really careful, and don't forget that whatever you do to the bottom, you do to the top. So that's why you also have to multiply the top or the numerator also by the square root of 2. So whatever you do to the bottom, make sure you do to the top. And so that's your final solution right here. Okay, and number 6, same process. This was a little bit more work, but not terribly so. Hopefully you guys were able to check that you're looking for a cube root, so you're looking for sets of 3. So hopefully you guys would see there was 5 p's. It looks like 3 q's. So the q was able to get pulled out of the radical because there were 3 of them, and there are 5 p's, so you only take out a set of 3. So there's just 1 p that gets pulled out, and you get left with 2 inside. And it still has, so the p squared gets stuck inside. And then your denominator is a square root of 40. And you guys are able to simplify that out, hopefully. I'm sorry if that's square root, it's cube root of 40. So hopefully you guys are able to get 2 times the cube root of 5. You cannot have a radical on the denominator. It doesn't matter if it's a cube root, a square root, a fourth root, a fifth root, it doesn't matter. You can't have that. So one of the most challenging pieces for students is rationalizing the denominator. It's a cube root. That means you have to have 3 of the same number. So instead of multiplying it like on the other problems, we multiplied it by itself, like the square root of 5 or the square root of 2. This is a cube root, so you'd have to multiply it by itself 2 times. Because you need, or to get rid of it, you would need a set of 3, right? You've got 1, but you need 3. So that's why you have to go ahead and multiply it by a couple more. So now when you think about it, now you have 2 times the cube root of 5 times 5 times 5, and now you have 3 of them. And when you simplify it out, you just get 2 times 5, which is equal to 10, and that's your new denominator right here. And don't forget that you also do the same thing to the top. So you multiplied the bottom times the cube root of 5 times 5, which is 25, cube root of 25, and that's why the 25 gets kind of stuck inside here. Okay, so whatever you do to the bottom, do to the top. And if you guys want to pause it and just kind of follow my steps, you are welcome to do that. If you guys have more questions, be sure to ask me this week. You do have a quiz coming up next week, and you have an exit ticket on Thursday. Your exit ticket on Thursday will actually be adding and subtracting radicals, which is what we're just about to do. So make sure you guys are following along. You are welcome to always pause it and rewind it. Moving over to our notes for today, make sure that you guys have these up where you can write on them. Some of you guys are probably, hopefully, watching the video from your phone, and then you can use another device to write on it, or you can write on this device and watch it on from another. Some of you guys are doing that, I see, which is kind of cool if you have that availability. Some of you don't, and that's fine. And if you don't, then I would just use a piece of notebook paper and I would just write it off like that. And a lot of you do, because I see a lot of your notes coming through, and it's fine. That's the most simplest way to do it and the best, because we learn by as many senses as possible. So writing and watching and listening, there's a lot of senses involved. So I agree that just writing it is good to go. All right, so real quick, a couple of reminders. We're going to talk about like radicals. So you can only add and subtract radicals. We've been talking about multiplying them and dividing them. You can only add them and subtract them if they're like terms, so what we call like radicals. So when you look at this, like for example, just kind of be thinking old school, 3x squared times 2x. 3 times 2 is 6. And remember, when you're multiplying variables, you're adding the powers, right? So it's really x cubed. There you go. Multiplying is just fine. Pretty quick. You don't have a bunch of rules to follow. You just kind of add them all up. Multiply and add up the powers. When you're adding them, remember, these are not like terms. So I'm going to make a note right here. Because you have the power 2, and technically this is a power 1, those are not like terms. Now, they both do have an x, but you have to have the same variable and the same power. And we've gone over this before, so I'm not going over that right now, but you know those are not like terms. You cannot combine them together. You can multiply them, but you cannot add them together. And that's really the biggest difference. So the same thing with like radicals, they have to have the same index and the same radicand. So they're just like adding and subtracting where they're a little bit fancy. So for example, 2 times the square root of 7 and 3 times the square root of 7, you can add them together and you can get 2 plus 3 is 5 times the square root of 7. So if you think about it, it's kind of like saying 2x plus 3x gives you 5x. Kind of the same idea here. Make sure that it has the same index. These are both square roots, right? So just make sure they're both square roots or cube roots or fourth roots or whatever. You can add them. You're only adding up the coefficients. You're only adding up the coefficient here with the coefficient here. So 2 plus 3 is 5. So it's 5 times the square root of 7. That's it. So make sure they have the same index and make sure that they have the same radicand. So what we're going to have to do today is we're going to have to get some of these numbers that don't have the same radicand and kind of manipulate them so they do, and so you can add them or subtract them. Okay, I know it's frustrating for some of you when you actually have to do the manipulations. That's where those brain cells are like really, really working, when you guys have to rewrite the numbers or the variables a little bit differently. You're not changing their value, you're just rewriting them. So let me go ahead and go through these examples with you guys real quick. Here's our first one, example 1. Just has 2 terms. We have 4 times the square root of 8 plus 3 times the square root of 50. They are both square roots. They both have the same index. They're both powers of 2, but they do not have the same radicand. One of them has an 8 and one of them has a 50. So what we're going to have to do is we're going to have to get them to have the same radicand. So you can just make a note if you need to. Needs same radicand, which is your number underneath the symbol. So we're going to do that. This is where we're going to kind of mess around with it. Okay, I need them to have the same radicand. So I'm going to just do 4 times the square root of 8. But instead of 8, I'm going to rewrite it. I know 8 divided by 2 is 4. So you can look at it like 4 is also 2 squared. Do you guys see that? So that's 2 times 2 squared. So 2 squared is 4. 4 times 2 is 8. It's 8, right? That's 4 times the square root of 2 times 4, which is 8. It's the same thing. So I'm rewriting that. You can do the same thing with 3 times the square root of 50. So you're like, okay, 3 times the square root of 50. I have 2 to the power of 2 here, and that's going to be simplified out because 4 is a perfect square. So I'm going to try and see, 2 can go into 50, right? Can't 2 go into 50 like 25? Isn't 2 times 25 50? It is. So I'm going to rewrite this guy as 2 times 5 squared. So I have 2 perfect squares here. When you do that, you can now simplify it out. So now you guys are going to have 4 times 2 times the square root of 2 plus 3 times 5 times the square root of 2. Because hopefully you guys are noticing, I don't know if that worked actually. Hopefully you guys are noticing that this 2 squared got moved here and this 5 squared got moved here. So that's not new. We've been doing that for a couple weeks now. So 4 times 2 is 8 times the square root of 2 plus 3 times 5 is 15 times the square root of 2. And you can go ahead and now you can go ahead and combine them. So it'll kind of be like 8 plus 15 times the square root of 2. So 8 plus 15 is 23 and the square root of 2. So once again, it's kind of like saying 8x plus 15x is 23x. So that's it. So your goal is to get the same radical, and then you can add the coefficients, so to speak, in the front. All right. So just remember, you're still simplifying radicals, but you're taking it down another step. So let's do the same thing with example 2. Hopefully you guys are looking to see, okay, are there any like radicals? I have a square root of 45, a square root of 80, and a square root of 20. They're all square roots, they all have an index of 2, but they do not have the same radicand, so we're going to have to manipulate it again. I'm going to change my ink color so they don't like run all together. We'll do blue. You guys like blue. Okay, so let's go ahead and do the same thing here. So let's go ahead and start with the first term. Let's go ahead and start with that 3 times the square root of 45. I know 5 can go into 45, it's prime, and I know that 5 times 9 is 45, right? We know that. But instead of writing it, well, I can write it like this, 5 times 9, if you want. Let's do the next one. Oh, that's a minus. Okay, so we have minus 5 times the square root of 80. Okay, well, I know 9 is a perfect square. I know 9 is a perfect square because square root of 9 is 3. So probably 5 can go into 80. I'm just trying to think. I'm trying to get these all the same. So I'm thinking that means the 5 is going to stay inside the radicand. So I need another number that's going to stay inside the radicand. So that's 5. So I know 80 divided by 5 is 16. So I'm going to do 5 times 16. And I'm going to try the 4. 4 times the square root of 20. I know that 20 also is divisible by 5. And that would be 5 times 4. Gives me 20. And hopefully you guys can kind of see maybe a little bit better that I'm just rewriting these. I'm messing around with them, just rewriting them as some perfect squares. 16 is the same as 4 squared, right? And over here, 4 is the same as 2 squared. So I'm just rewriting them. You see how there's perfect squares here now? And then they all have a 5 inside. So once I rewrite them, it's going to be 3 times the square root of 5 minus 5 times 4 times the square root of 5 plus 4 times 2 times the square root of 5. And look, they all have the same radicand now. And once again, just be on the lookout. We had a square, a power 2, and a power 2. And that we brought that here. brought that 4 squared here, and we brought that 3 squared here. Okay, so, and you guys don't have to do that stuff. Hopefully you guys can see, oh, square root of 9 is 3, square root of 16 is 4, square root of 4 is 2, and you can skip that whole stuff right there. I'm just doing that so you guys can see it. Let's go ahead and finish taking it down. So 3 times 3 is 9 times the square root of 5 minus 5 times 4 is 20 times the square root of 5 plus 4 times 2 is 8 times the square root of 5. And now you guys can go ahead and combine like terms. You have 9 minus 20 plus 8. We're going to go ahead and combine those and just leave the square root of 5. So 9 minus 20 plus 8 should give us a negative 3 times the square root of 5. Okay, so that's what you guys should have gotten for example number 2. So I'm going to give you guys one more example to work on. I'm going to pause the video. I want you guys to try negative 4 times the square root of 18 plus 5 times the square root of 20 minus 2 times the square root of 98. Try to make sure these all have the same radicand, so then you can go ahead and just add the coefficients in the front. So I'm going to pause the video. You're going to pause the video and you're going to try this right here, and then you're going to come back and check and see if we got the same thing. All right, so hopefully you guys were able to check number 3, and hopefully you guys were able to combine like terms, and you guys were able to get the same radicand as the square root of 2. And just add up your coefficients, which were negative 12, positive 25, and negative 14. You can write it either way as a negative 1 times the square root of 2, or you can write it as just a negative square root of 2. Either way is okay. So you guys are welcome to pause the video and see how I wrote that and make sure that it's kind of coming together. These are kind of nice. There's no variables in here. It's just numbers. So, which I don't know how you feel about that. Pros and cons, I guess. All right, so here's what you guys are going to do today. And you guys are going to work on this right here. Okay, so this is the second page. And once again, this is actually in your green workbook. If you don't want to use my document, you can use your own because you guys all have your workbooks except for a couple of you. But anyway, so you're welcome to get this file, or you guys can just write on it from here. And like I said, there's a couple more examples up here if you need to use it. Or example 1, example 1 would actually be what we just did, if you want to look at another example with some larger numbers. But the way I did this, and you're welcome to move forward if you want, the pink ones are the only ones you have to do today. So you only have to do problems 1, 2, 3, and 4. Those are just the adding and subtracting problems. Number 4 is multiplication. We did that the other day, so I figured you guys could go ahead and try 4. We're going to do, it's really the same process, but we're going to kind of FOIL and distribute problems 5, 6, 7, 8, and 9 on Thursday. And then we're going to do some more division with problems 10, 11, 12 on Friday. So I section them off into 3 different colors, if you can see that. So those are your assignments kind of in order for Wednesday, Thursday, and Friday. So for Wednesday, it's really just the pink, or I think it's magenta ones. 1, 2, 3, and 4 you guys can do today. If you need help, come and see me in the post office. Make sure you guys take your notes first. I don't expect you to remember it. I don't do math in my head. I've done these problems so many times before I make my videos, so I don't expect you to do them in your head if I don't do them in my head, okay? So do your work. If you guys need help, just let me know, and be sure to turn your work and have a great day. Bye, guys.